Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So we are discussing about this engineering tribology subject. So in this subject, the main important parameters are friction, wear and lubrication, and then corrosion. So how to control this corrosion and how to avoid wear and how to minimize the friction. All these things we have studied in the previous sessions. So today I want to discuss about what are the main factors influencing corrosion. So what are the factors affecting the corrosion and then controlling methods. How to control, how to prevent this corrosion. In last session, I have discussed about types of corrosion and then the methods of the mechanism of corrosion we have studied. So in today's topics are factors influencing corrosion and then corrosion control methods we will see. So the main factors affecting the rate of corrosion, there are some factors affecting on the corrosion. So the rate and extent of corrosion mainly depends upon the nature of metal and the nature of environment. So that's why we should learn the metal properties. So what are the important properties of metal? First of all, you should know should know the material classification. So what do you mean by metal? What do you mean by non-metal? So what is the composition of the particular the metal? So suppose if you want to design a component in mechanical engineering, first you should know the mechanical properties of the particular metal, which metal we are using, the strength, hardness, fatigue property, so plasticity. So all these properties you should know before going to start the design. So that's why this the rate and extent of the corrosion depends upon the nature of metal. So which type of metal you are using, and the nature of environment. What are the atmospheric conditions, the working conditions? That also main factor affecting of this corrosion. So the factors affecting rate of corrosion, the nature of metal and the nature of environment. We will see here in a tabular form the purity of the metal. The nature of metal is purity of the metal. The temperature, nature of environment is temperature. The physical state of metal, that is nature of metal. Then the humidity in air. So how much of humidity present in air, atmospheric condition, atmospheric weather. Next, in the nature of metal means nature of oxide film, and then position of metal in galvanic series. So relative areas of anode and cathode, and solubility of the product of corrosion. So what is the solubility percentage of the product of the corrosion, and electrode potential? All these things you should know. You should learn about this the nature of metal. Why? Because this nature of metal, the affecting rate of corrosion depends upon this nature of metal and the nature of environment. So purity of metal, physical state of metal, nature of oxide film, relative areas of anode and cathode. So the small area and the larger area of the anode and cathode. The mechanism depends upon this area of anode and cathode, the solubility of product of corrosion, electrode potentials. So similarly, the nature of environment, temperature, effect of pH value, the conductance of the corroding medium, and then presence of suspended particles, impurities in atmosphere, amount of oxygen in the atmosphere, how much oxygen present, how much amount of oxygen present in atmosphere you should study. So all these things are very important related to the corrosion. Without knowing these the nature of metal and nature of environment conditions, suppose if we have designed a particular component, use it for a specific application, then ultimately what will happen is after some time it will be corroded. So why? Because you are not seeing any nature of environment, you are not seeing any nature of metal. So that's why the important the factors the you should know for using before using the particular application. So then only it will be safe. The factors due to nature of metal, one by one we will see. The first one is purity of metal. The purity of metal means heterogeneity of the metal is due to the presence of impurities which form tiny electrical chemical cells at the exposed parts, very small electrical chemical cells at the exposed parts, the anionic parts get corroded. The second one is electrode potentials, means the metals with higher reduction potentials do not corrode easily. So they are noble metals like gold, platinum, and silver, whereas the metals with lower reduction potentials readily undergo corrosion. Example: zinc, magnesium, aluminum, etc. So all these things comes under this electrode the potentials. So which metals have having the higher reduction potentials? The metal do not corrode very easily. So they have some strong protection against this corrosion. The position of metal in galvanic series. So metals which possess low reduction potentials and occupy higher end of the galvanic series undergo corrosion easily. In previous case already we have seen the high reduction potentials does not undergo corrosion easily, but low reduction potentials undergo corrosion easily. So metals which possess high reduction potential and occupy lower end of the galvanic series do not undergo corrosion, already given in this line. They get protected. When two metals are in electrical contact in presence of an electrolyte, then the metal which is more active undergoes corrosion. So this process is called galvanic corrosion. In types of corrosion already we have studied. When two dissimilar metals are connected in electrical contact in the presence of electrolyte, the metal which is more active undergoes corrosion. So the rate of corrosion depends on the difference in their position in galvanic series. Greater the difference, more will be the extent of the corrosion at anode. So that's why the rate of corrosion depends upon this position of metal in galvanic series. Next, relative areas of anodic and cathodic. So the relative areas of corrosion is influenced by cathodic to anodic cells. So suppose if the metal has some small anodic and large cathodic area, the rate of corrosion is very high. Suppose same metal, the high anodic and small the cathodic area, so the corrosion rate is very low when compared to previous one. This is because the electrons are liberated at anode which is consumed at cathode. So the electrons are flow from anode to cathode. So if the cathodic area is larger, the liberated electrons are rapidly consumed at cathode. This further enhances the anodic reaction, leading to increase the rate of corrosion. So this is the difference between these small anodic and large cathodic area. That's why this corrosion depends upon these areas of this anodic and cathodic areas. Next, physical state of metal. Metals with small grain size have more tendency to undergo corrosion. Metals with more stress or strain also undergoes corrosion easily. So this physical state of metal are studied in granular corrosion. So this granular corrosion depends upon this corrosion depends upon this uh, the grain size. So the physical state of metal, when the small grain size have more tendency to undergo corrosion. So similarly, the large grain size have low tendency to undergo corrosion. So this is one important thing in the physical state of metal. Next, nature of surface film, also called as this metal oxide layer. If the corrosion product formed is more stable, insoluble, and non-porous, it acts as protective layer and prevents further corrosion. So example, Ti, aluminum and chromium. If the corrosion product is porous, volatile and soluble, it further enhances the corrosion. So ferrous, zinc and magnesium. The previous all points comes under the nature of metal. Now the second one is the factors due to nature of environment, temperature. So the rate of corrosion reactions increases with increase in temperature and decrease with the decrease in temperature. The rate of corrosion depends upon these reactions, temperature value. The reactions depends upon this temperature. If the temperature increases, the metal some metals are undergone corrosion. Similarly, the humidity in air, the moisture or humidity present in atmosphere furnishes water to the electrolyte, which is essential for setting up of an electrochemical cell. So suppose if more humidity in the air, the rate of corrosion also very high. If humidity is less, the rate of corrosion is very low. So that's why you should know the humidity percentage in the air before using the product. The oxide film formed has the tendency to absorb moisture, which creates another electrochemical cell. So all this comes under nature of environment. Next, pH value. The pH value of the medium has the greater effect on corrosion. Acidic pH increases the rate of corrosion. The basic pH decreases the rate of corrosion. So that's why the pH value is very important. So this when the product using in different environmental conditions, you should know the value of this pH. The presence of impurities. Atmosphere is contaminated with gases. So many gases mix it in the atmosphere. So like CO2, SO2, H2S, fumes of H2SO4, HCl, etc. and other suspended particles in the vicinity of industrial areas. So they are responsible for electrical conductivity, thereby increasing the corrosion. So that's why the presence of impurities also one major factor affecting of corrosion. Next, amount of oxygen in atmosphere. As the percentage of oxygen in atmosphere increases, the rate of corrosion also increases due to the formation of oxygen concentration cell. The decay of metal occurs at the anodic part and the cathodic part of the metal is protected. So that's why the amount of oxygen in the atmosphere also one factor affecting the corrosion. Next one, corrosion control methods. So how to control this corrosion we will see in this PPT. Electrochemical protection or cathodic protection. The principle involved in the electrochemical protection or cathodic protection is to force the metal to behave like a cathode. Again, this electrochemical protection or cathodic protection, two types, classified into two types. One is sacrificial anodic protection and another one is impressed current cathodic protection. So the main principle involved in electrochemical protection or cathodic protection is to force the metal, which metal we are using, the metal to behave like a cathode. First we will see the sacrificial anodic protection. In this method, the metallic structure to be protected to behave like a cathode by connecting it with more active metal. So the active metal is anodic metal. So that all the corrosion will concentrate only on the active metal only. So in this method, what you are doing, the protect the base metal you are forced to behave like a cathode by connecting with more active metal, another metal, active metal, that is anodic metal. So in this process, what will happen? The corrosion will concentrate on this active metal at anodic. In this case, the cathode parties will be safe. So like this, you can control you can protect the part from corrosion, the metal from corrosion. The artificial made anode thus gradually gets corroded, protecting the original metallic structure. Hence, this process is otherwise known as sacrificial anodic protection. So, aluminum, zinc, magnesium are used as sacrificial anodes. The anodic metals, the active metals, the using metals are here aluminum, zinc, and magnesium. These three are main metals used as sacrificial anodes. See in this diagram, shown the sacrificial anode protection, the oxidation, anodic, and moisture soil, the pipelines are cathode. This, so you have to protect this pipeline from the corrosion. So that's why this metal behave like a cathode. The another one is the oxidation metal, that is sacrificial anode, the magnesium, used as a anodic metal. So all corrosion will be occurred at this anode position only, anode metal. So by this you can protect this pipeline from corrosion. This method is sacrificial anodic protection. See, underground cables and pipelines are protected from this method, corrosion, by using this sacrificial anodic method. See the corroded part, you can see in this diagram, cables and pipelines. The important application of this method are protection of underground cables and pipelines from soil corrosion. Anodic protection, another application is in ships and boat hulls from marine corrosion. The hulls, and here in this diagram you can see the protection of the ships. So in this sacrificial anode, zinc metal and protected base metal. This base metal protected from the corrosion by using this sacrificial anode, that is zinc, the protected base metal. The sacrificial anodic protection, the protection of ship hull below waterline. The important application of this method are prevention of rusty water by inserting magnesium sheets or rods into domestic water boilers or tanks. So you can see here in this the boiler tanks, domestic water boilers. In this, to avoid the rusty water, inserting magnesium sheets. So these magnesium sheets act as a anodic. So next one is impressed current cathodic protection. So the second method, in this method, an impressed current is applied in the opposite direction of the corrosion. The corrosion current, which current is passes through the metal. So here they applied in opposite direction of the corrosion current to nullify it. So, and the corroding metal is converted from anode to cathode. This can be done by connecting negative terminal of the battery to the metallic structure to be protected, and positive terminal of the battery is connected to the insert anode, inert anode. So to be protected part, the battery, the negative terminal of the battery to the connecting to the metallic structure. So other one, positive terminal of the battery is connected to an inert table. So inert anode. Inert anodes used for this purpose are graphite flattenized type. The inert anodes materials are graphite flattenized titanium. The impressed current cathodic protection shown in this diagram. The source of current are DC anode and cathode here shown. The graphite anode, the soil, and in the, insulated on the copper wire. The pipeline or cathode. This part is to be protected from the corrosion. So in this, you have to apply the negative opposite direction current to nullify the original process of the current. So that the inert metal act as a anode. To impress the current cathodic protection. The rectifier drives the corrosion current to simulate the anode corroding. So in this diagram shown, so in this the protected the pipeline is given. The rectifier drives the corrosion current to simulate the anode corroding. The impressed current cathodic protection. The anode is buried in a backfill containing a mixture of gypsum, coke, breeze, and sodium sulfate. The backfill provides good electrical contact to anode. The pipeline shown here to be protected, and anode and backfill. The backfill materials are here given gypsum, coke, and breeze. So that it provides good electrical contact to the anode. The impressed current cathodic protection applications are structures like tanks, pipelines, transmission line towers, underground water pipelines, oil lines, ships, etc. can be protected this method. So what is the difference between this sacrificial anode and impressed current method? So in this, the sacrificial anode method, the external power supply is not required. But in this case, impressed the current method, the external power supply is required. Here current is using, so in opposite direction, but here no need of current. The cost of investment is very low. The cost of investment is very high in the case of impressed current method. And this requires periodic replacement of sacrificial anode, and the replacement is not required as anodes are stable. Next point, the soil and microbiological corrosion effects are not considered here. But in this case, the impressed current method, the soil and microbiological corrosion effects are taken into account. And next point, fifth point is, this is the most economical method, especially when short-term protection is required. But in the case of impressed current method, this is well suited for large structures and long-term operations. The sixth point is, this is suitable method when the current requirement and resistivity of the electrolytes are relatively low. So wherever, so not possible to use current and not available the electrolytes. So in those places you can use the sacrificial anode method. But this is suitable method even when the current requirement and the resistivity of the electrolytes are very high. In those conditions also it very suitable this impressed current method. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.